In this video module, I'm going to go through a few sample Python programs, and all of these programs are found in a Jupyter notebook in our GitHub repository. Before we look at the programs, I want to mention what my objective here is. As I've said before, this is not a programming class, so the basic objective I have is not to teach you to program, but we want to use the tools in primarily an interactive way. And so I'm going to go through some programs. I'm going to go through some programmatic constructs here, but I don't expect you to understand all of the details. I don't expect you to be able to recreate these in the future. The objective here is that you can just see how we are using Jupyter and how the Python structure is used. And so you'll always be able to refer back to these when we're doing our work in the class, as we're going to refer back to the examples that we have here and then further examples that we have. So I say this so I don't want you to be concerned as we're going through some of these programs if you're totally lost or you just are not used to doing this type of programming, because that's not our objective. We're just trying to expose you to how this works and to give you some visibility into the tools themselves. So I'm going to start from the beginning here. So let me just get out of my PowerPoint here. And the first thing I'm going to do is open an Anaconda prompt. And then from the Anaconda prompt, I need to navigate to the directory where I store the Jupyter notebooks. And so for me, I have a batch file and I store those in my documents directory, GitHub subdirectory, infotech for ops. And if you just do a dir directory there, you'll see the three directories that are in the GitHub repository. And so now I need to start Jupyter from here. Jupyter Notebook. Oh, Jupyter Notebook, if I type it right. It starts Jupyter and brings up the browser. So let me zoom in here a little bit. Zoom in a little bit more. There we go. And we're going to go to Notebooks. And the notebook that we want is Sample Python Programs 1. So if we just click on that, it will then open Sample Python Programs 1 Jupyter Notebook. The first program we'll look at takes a list of numbers that I have here as numbers and computes the sample average. And so what I used in this for this first example is what I would call a programmatic approach, where I define an accumulator named total. So this defines a variable named total and assigns it a value of 0. A counter named count. So again, I'm defining a variable named count and assigning it a value of 0. And then I use a for list where I iterate through a Python list. So this iteration operator, this iteration statement will basically assign the value of 1, 2, 3 to the variable num, and then the value of 87 and 96 and so on. And so it just sequentially assigns all of the values in the list. And for each value, it increments our total using that number, and then increments the counter. And so what happens is, as I go through this loop, I'm going to add 123 to 0, then add 87 to the sum, then add 96 to the sum, and then add 24 to the sum, and so on. And I'm also going to add 1 to count, which is 0, and then add 1 to that, and 1 to that, and 1 to that. And so you can see as I go through the loop, I'm going to accumulate my total and count the number of observations. When I get to the last number in the list, then I'm going to exit the loop, come to this if statement, and where I'm going to test and say, if count is greater than 0, because in order to compute the average, I need to divide by count. And so we assign count a value of 0 back in the beginning. And so I need to make sure that I've actually incremented that. Otherwise, I'm going to get a divide by 0 error. And so if I execute, just do a shift enter, you can see the average of the 14 numbers is 246.774. And so that is the output that we get from our print statement right here. You can check this if I go and say, well, what if I deleted everything in the list and then executed? Now we dropped immediately out of the for loop because there's nothing to accumulate. When we tested the if condition, count is not greater than 0, and so we dropped down to the else and printed the sample size of 0. And so I would encourage you to do some additional experimentation here, add some different numbers to the list and so on, until you're comfortable with what's actually going on in the code. Okay, so I'm going to use Control Z and undo everything that I just did, bring my original list back, Shift Enter so that I can get back to my 14 numbers. As I said, this is what I would refer to as the programmatic way of computing the sample average, where I actually go through an iteration, I do an accumulation and accounting, and I have an explicit if condition. The second example we're going to do is the same thing. We're going to do the same operation, but this is what I'm going to call the Python-esque version for computing the sample mean. In this case, rather than using a traditional programmatic approach, I'm just going to use some of the built-in functionality associated with Python. And so you'll note here I've defined the same list called numbers, except this time I only have this single line, the single print. And so I have basically the same print that I had right here. I just simply have, instead of the average and the count, I'm using the length function for numbers, and then I'm using the sum function that's built into Python to compute those values. And so I'm going to have Python compute the sum for me and the count for me. So when I execute that, you can see I get the exact same value, the sum of the 14 numbers, 246.74, by just using those values. Of course, in this example, I didn't do any error checking. So if I were to send it an empty list, then I would get a divide by zero error because I have the length of numbers is 0, but that's something that you could easily add. Okay, so for my second program that I'm going to have, or my third program here, if you count that average is 2 programs, is I'm going to compute a histogram of a set of numbers. And so the numbers that we have are given to us in a data file called data.txt, and that data.txt is stored in the data directory off the root directory of where from the GitHub repository. So I'm going to go back here and go back to my repository, which, as I said, is stored in Infotech for Ops. And this is going to be different depending on where you store it, but you should have some directory where you have the baseline. And so this is where we executed Jupyter Notebook. The data is stored in this data directory, and we're interested in looking at this file right here, data.txt. So we're interested in looking at this file right here. So if we open that just using the notepad, you can see that we have one integer per line, and we have some blank lines. And so what we want to do is we want to sequentially read these in one at a time and convert, when we read those into integers, and then I'm going to create a histogram based on those integer values. So once again, and this is important and sometimes confusing, when I look at this path right here, this is saying I want to go up one level in the directory structure, then I want to go into the data directory, then I'm going to read or open the file data.txt. If we look at our structure here, from within the notebook directory, here's our notebook. Right, here's our notebook right here, sample Python program. So the / says go up one level. Then the /data says go into the data directory, and there's where you'll find our file data.txt. So let's take a look at this comprehension that I'm using to actually read the values in. And as I've said in class and in previous videos, when I look at a comprehension like this, the thing to look at is go from inside out and left to right. And so the way we want to read this is I have a comprehension. That's what this the bracket means, the 2 brackets here, is that I'm creating a list. And so what I'm going to do is I'm going to say for I in open, and so what this tells me is I'm using a file iterator, a built-in function of Python, a file iterator. And so what this does for I in open, it opens the file and then sequentially assigns the next line of the file to the value I. And then what I'm going to do is I'm going to use the rstrip function. So when it reads I, it's reading it as a string, and rstrip strips any trailing white space. In this case, what it's going to strip is the newline function and any spaces that are there. And so what happens is I.rstrip is going to just return what's left after you get rid of the newline character and any space. Then I'm going to convert that to an integer. And I have this if condition here that says if I rstrip so that I can test for blank lines. And so what's going to happen is if I have a blank line, once I do rstrip, then the string is going to be empty and it's going to fail this condition. So this is something that you should definitely explore further. And so one way, if this is not clear, you should explore this further. And so one way you can do that is if you just insert a cell above, and then we can just copy this right here. Just take that line and copy it, and then you can see what's happening when you read that. So I'm just going to print the value there, and then I do Shift Enter, and you can see these are all of the values that get read. And so you'll notice there are no blank lines because we've stripped those out. If I go and say get rid of this statement, let's say that I get rid of this. I get rid of that conditional, and then I run. Now I'm getting an error. It's saying, wait a second, you have a literal, and what's happening is I've read a blank line right here, and when I strip the value, it says, wait a second, you can't do this because it's a blank. There's no way that I can convert that into an integer. And so you can see that's why we're using this if condition for if there's a blank line. Okay, so once we execute this statement, we have a list of integers. And so what we're going to do in the data structure for this program anyway, is I'm using a dictionary that I call hist. And so I'm initializing the dictionary, and then I'm just going through and setting all of the initial values equal to 0. And so note how I'm doing this with the histogram is I'm using range. I'm taking the minimum integer from my list and the maximum integer from my list, and I'm getting a range value in between those. So again, if I insert a cell above and say, let's do some experimentation. Let's say A is equal to 5, B is equal to 10, so let's assume 5 is the minimum and 10 is the maximum. And then I'm going to do for I in range AB, and let's just print I. Print I. And you can see exactly what's happening is it's iterating through the values, starting with A, 5, going up to but not including B. So we have 5, 6, 7, 8, and 9. And so again, you can experiment here and put some additional values here, but what's happening is I'm taking the minimum value that I read from the file and the maximum value that I read from the file, and I'm iterating between all values in between. Right? And so this is how I'm keeping track of all of the values in my histogram. So I'm initializing all of those to 0. Then I'm going to loop and say, okay, I want to read all of the values, read each value individually, and I'm going to use the value as a key to my histogram. And so I'm just incrementing the value from the previous one. And then I'm going to then display the sorted values. So when I run Shift Enter, you can see that we had 2 zeros, 3 ones, 2 twos, 6 threes, 3 fours, 7 fives, 0 sixes, 4 sevens, and so on. And so what I'm in essence doing for my histogram is I'm just counting all of the numbers of times that each individual integer appears in my file. In the next program, I'm doing something similar in that I'm creating a histogram, but I'm doing two things differently. First of all, rather than accumulating the counts, I'm using the count function, which we'll see in just a second. And secondly, rather than displaying a text version, I'm using matplotlib to display a graphical version. Now note that later in the class, in a couple of weeks, we're going to talk in detail about matplotlib. So just think about these as function values for now, and we'll come back and talk about those in detail. But what I need to do for this program is I need to set up matplotlib, and so what this first magic command does is says I want to show inline versions of the graph. Then I'm going to import the module, so import matplotlib.pyplot as plt. So this is essentially creating a namespace called plt that stores the functions. Then I'm going to read the values in just like I did previously. I'm going to define my dictionary for my histogram, but instead of going through each value individually, this time I'm going to go through the same range, the range the same way that I did before, but I'm going to directly assign the histogram value using the vals count I. And so let's create a cell above and just see how this happens. So if I do vals count 0, it returned that 2 value. And so if we scroll back up, that's the 2 that we got here. If I want to see this one, for example, 5, I can just put my 5 in here, and it's giving me that 7 value. So when I did the program above, I just iterated through all of the individual values and then incremented the corresponding dictionary value. In this version, instead, I'm just counting directly, and so I'm making a direct assignment. So in this case, I just go through each one of the integer values. Nevertheless, when I come out of this line right here, my histogram dictionary is going to have the exact same values that we saw here. So if I were to go back and print these, use the same print statement, we would see the exact same thing. But in this case, what I wanted to do is I wanted to plot the histogram. And so let me just start that, and you can see we have a histogram that has those observe count values. So note a couple of things here is that we didn't explicitly say how to do the binning. Right? We just said I want to have 15 bins, and so we're seeing values that were grouped together. That was done automatically by Matplotlib. But you can see I created the histogram by just using a series of function calls. So I created a figure, then I set the y ticks and x ticks. So the y ticks are this axis, the x ticks are this axis. Then I said create a histogram using vals. So these is the counts that we had. I want 15 bins, and I don't want those bins to be normed, and set the title equal to observed counts and use a font size of 10. So these commands up until the PLT show create the histogram, and then the PLT show actually shows the histogram. The next function that we're going to see is I'm going to define a function that does what's called a quicksort. So a quicksort is a standard way to sort a list of numbers, and it uses a partitioning approach with recursion. And I've given you the reference here that we used to create this function, so you can look that up if you want to see all of the details. But essentially what I did was I defined a function, so I used the diff statement, diff quicksort, and I passed one parameter called the list. And as I specified here in the comment, the list should be a list of numbers. So in this case, I didn't do any error checking to make sure that that's the case. I'm just assuming that it is. And what I define is I define 3 lists, a list called less, a list called equal, and a list called greater. And the basic idea of the quicksort is I'm going to sequentially define these 3 lists. I'm going to put all of the values that are less than a particular value called the pivot in the less list, all the values that are equal to the pivot in the equal list, and all the values that are greater than the pivot in the greater list. And then I'm going to recursively call the quicksort function. So what we're doing is if the list is greater than 1, I'm going to define the pivot as just the first element in the list. So this is the number that I'm going to pivot on. Then I'm going to sequentially go through the list using x in the list. So again, this will sequentially assign the variable x to each value in the list. And so if x is less than the pivot, I put x into the less list. If x is equal to the pivot, I put x in the equal list. If x is greater than the pivot, I put it in the greater list. And so as we go through this list, it will loop through here once for every element of the list. And so when we jump out of the list, I'm going to have 3 lists. One of the lists is all the values less than the pivot. The equal list has all of the values equal to the pivot, and the greater list has all of the values greater than the pivot. And so now here's where I'm going to do the recursion, is I'm going to concatenate, 3 lists, my less list, my equal list, my greater list, but I'm going to recursively call the quicksort routine. And so what happens is it recurses until the list length is 1, as you see right here. When the list length is 1, we fail this test, we jump into the else, and we just return the value. And so we're going to recurse down until the list has a single element, and then we're going to bubble back up. And so you can see when I execute that, I defined the function, and then I just made a call, print the quicksort of 12, 4, 5, 7, and so on. And so we have defined the function, and so in the cell below it, I'm just going to make a function call, right? Because I've already defined the function, and so I don't have to go through that redefinition. So what we demonstrated here is how to define a function that takes a list as a value, returns a list as the return value, and then I made one function call to demonstrate, and then in a subsequent list I made the second one. So again, I would encourage you to have a look. Go have a look at this web page if you have any questions about how the quicksort works. In our case, we're not particularly interested in the mechanics of the quicksort as much as we are how Python is partitioning the list and then using this recursion call. So moving on, just a couple more samples to go. The next one, I'm going to use something called the Mueller Method for generating normal random variates. And so I've adapted from this website that talks about how to do this transformation. And basically what I'm doing in the subroutine, or what I'm doing in this demo, is I'm going to use NumPy, and I'm going to use NumPy to generate some random variates and then do some of the math functions. I'm going to define a function called Gaussian, which will actually convert or take the uniform random variates and return corresponding normal random variates. Then I'm going to use the NumPy functions to generate the U values. And so basically how this works, and then finally I'm going to do some plotting using Matplotlib as we did before. So we're going to talk about NumPy next week, so just bear with me here on this for this program. And you can see what I'm doing is I'm defining a function that takes two parameters, U1 and U2, and then generates the Z1 and Z2. Right? And so by using this using this Box-Mueller transformation. So basically what I'm doing is I'm doing minus 2 times the log of the first u times cosine 2 pi of the second u. So each one of the z's takes both of the uniforms. So u1 and u2, u1 and u2, and I create 2. So the way the Box-Mueller method works is it says I'm going to take 2 uniforms and give you back 2 normals, and that's what we see here. Now, one thing to keep in mind that we're using NumPy here, that NumPy is a vectorized package, and so it does vectorized math similar to MATLAB if you're used to that. And so what this function call does, random.rand 5000, it's going to generate a vector of 5000 uniforms that I call u1. Then I'm going to generate a vector of 5000 uniforms that I call u2. Then I'm going to call the Gaussian function using these 2 vectors. Now note, when I was describing the Gaussian function before, I said it takes 2 u's, u1 and u2, and generates 2 z's. But because we're using vectorized math, we're using NumPy, what's going to happen is it returns the vector u1 and u2. It takes the vector u1 and u2 and returns the vector z1 and z2. So when we come out of this function, z1 and z2 are each vectors of 5000 normal random variates. And so when we get here, we have the normal random variates, and so what this function does is it generates the plot. So let me just execute this and I'll show you what's going on. As I said, we're going to talk about Matplotlib and NumPy next in the class, but let me just give you a sort of foreshadowing of how this works. PLT, we created a plot. Then in this plot, I'm creating a subplot. My subplot has 4 components. And so basically this 2, 2, 1 basically says I'm going to create subplots where I have 2 rows, 2 columns, and this is cell 1. And I'm going to plot my first vector of u's. Then here's my 2 rows, 2 columns, the second cell, and I'm going to plot the second u. So here's my u1, my 5000 u1s, and here's my 5000 u2s. Then I'm going to take my 2 rows, 2 columns, third cell and plot z1. That's what you see right here. 2 rows, 2 columns, fourth cell, that's right here, and plot Z2. And so once again, the difference that we see here is that we're using vectorized math, and then we're also using the Matplotlib subplots. Okay, so next As I say, of course, NumPy has its own function to generate normal random variates, so there's really no need to use the box Mueller method. In this case, I just imported NumPy as before, matplotlib as before, and I used a single call to generate, in this case, 1,000 normal random variates with a mean of 127 and a standard deviation of 36.5. So when I execute that, I just have my single plots, so I didn't use subplots in this case. I just wanted to demonstrate the fact that NumPy provided functionality to generate the normal random variate, so there's really no reason to use the box Mueller method, other than, of course, for demonstration purposes. Okay, so the last set that we're going to do, the last set of things, involves connecting to a MySQL database and doing an initial query. And so this assumes that you have gone through the installation process that I did for our software toolkit, and that you've created the database in the user, as I showed in the MySQL video. And so we're going to import the module, MySQL connector. We're going to do something called create a connection to the database. So CNX creates a connection. You just need to make sure that you have the user password and database set correctly. Then I'm going to print if you were successfully connected. I'm going to print the word table, so that's what these two statements do. And then I'm going to execute a SQL query. The SQL query that I'm going to execute is simply show tables, which shows the tables in the database that we've defined as INSY 6500. Then when I execute the query, I'm going to use what's called the SQL cursor, and then I'm going to iterate through those and print all of the individual values. So for now, all I want you to do is make sure that you can execute this, and you can see that the database, that you are actually connected to the database, so that you've appropriately got all the software installed, and then you can go through and see what's going on here. Again, we'll get to the details of what's going on with MySQL. The critical part for this section of the course is the Python aspect of the program. Okay, and so the last one that we're going to do similarly is making sure that we have pandas installed correctly. Pandas is the next thing we're going to do after we get finished with NumPy. And so what this program does is it imports pandas as PD. So I'm creating a namespace called PD. I'm creating a cursor connection to my database, just like I did before. I'm executing a second query. This time where I executed the query up here was show tables. This time I'm doing select star from SKUs. So in this case, SKUs, SKUS, is a table, and what this query does is say, give me all the values from the SKU table. We execute the query, and then we just, in one statement, get all of the table rows. And so what table rows is gives me a list of all of the rows of the table, and then I'm going to create that into what's called a pandas data frame, and then use the head function to say, show me the first few rows. So I'm creating a pandas data frame, I'm reading the data in from a database table, and then I'm showing the first few rows. So we hit enter, and you can see I'm showing the first 5 rows. We're indexed by 0 here, and we have the name, the SKU, the location, the quantity, and the category. We'll talk about all of those from the table a little bit later. The critical part now is that you can actually connect to the database, and that you can read the query, and that we have pandas appropriately installed. Okay, so if we can do all of these, then you should be set to go, and you should be able to refer back to these programs. So the simple programs, when we're working in the future and you need to work with pandas, or work with NumPy, or work with matplotlib, the basic idea is that we can refer back to this Jupyter notebook to get some of the function calls and to get us going towards the task that we're going to do in the future.